Okay, class, this is our last lesson in Chapter 4, 4.9b. We are going to use the Pythagorean theorem to identify right triangles. Now, notice that there's a double asterisk here. They are going to give you three sides. We have to determine whether or not they really make up a right triangle. Always use the longest side as the hypotenuse. So we're going to start with a squared plus b squared equals c squared. The longest side we are going to substitute for the c squared. So 7 squared plus 24 squared. Now we're not sure about this, so we are going to put in a question mark above our equal sign. 25 squared. Whoops, forgot my squared there. Okay. 7 squared is 49. 24 squared is 576. Is that going to be equal to 25 squared, which is 625? Over on the left side, I'm going to do the addition. 9 and 6 is 5, carry the 1. 4 and 7 is 11, plus 1 is 12, carry the 1 again. We're at 625. Yes, 625 equals 625. If you'd like, you can certainly hit pause and do sample B by yourself. Let's see how you did. 7 squared plus 8 squared, is that equal to 10 squared? 7 squared is 49, 8 squared is 64. Is that equal to 10 squared, which is 100? If I add 49 and 64, I'm going to get 113. And no, that is not equal to a 100. So a 7, 10, 8 is not going to be a Pythagorean right triangle. Sometimes when you are working with Pythagorean theorem, they will actually ask you to simplify the square root and to leave it in terms of square roots. And they also do this, by the way, on the math triathlon. So we are going to look at this and say, all right, we only have two sides and we happen to have the two legs. So that means I need to find the hypotenuse. So I'm going to substitute 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. This is where I use my reflexive principle and I go c squared equals 50. Again, the square root of c squared is c, so I need the square root of 50. Now, sidebar. The square root of 50 really means the square root of 25 times the square root of 2. What you do is you think about your perfect squares and you ask yourself, what factors of 50 will end up giving me a perfect square? And the factor is going to be 2 times 25. Now, another way of looking at this is saying, okay, the perfect square is 25 times 2. The square root of 25 is 5. The square root of 2 really isn't an integer. So I'm going to leave my answer as 5 times the square root of 2 centimeters. Let's try another one. A squared plus b squared equals c squared. 7 squared plus 7 squared equals c squared. 49 plus 49 equals c squared, so c squared equals 98. C is therefore going to be the square root of 98. Now, if you really look back at this, people, look what you have up here. You have 49 plus 49. That means 49 times 2. So the square root of 98 is really the square root of 49 times 2, which means I have 7 times the square root of 2 And I do not have labels here, so I have to use my word units, my label units. And that concludes lesson 4.9b on using the Pythagorean theorem. Scouting out.
I'm sorry.